Hi, folks. So today I'm going to talk about an API-first approach to adopting a distributed SQL database. The idea is to build like apps, modern apps with scale in mind. Right. Quick introduction about myself. Hey, I'm Praveen. I work in the community and development team at Hasura. I lead the content efforts at Hasura. So I'm also organizing a few meetups around the GraphQL ecosystem, GraphQL Backbone, so on. My stack looks primarily around JavaScript, both on the backend and front end, and Docker Kubernetes for the DevOps side of things. On the API side of things, it's primarily been REST APIs, and then there is GraphQL, which we'll talk about in the coming slides. The reason why it's just about APIs separately is because we typically think about front end, back end, in all of the databases and all of the stack and tools that we use, right? And in most of these cases, REST APIs, like by default, comes in to the picture. So GraphQL is a new paradigm in how you actually query data and query from multiple sources of data and get responses pretty quickly, right? So we'll talk about that as well. So before we dive in, let's look at the data access layer problem, which is you have a lot of these consumers, like your mobile apps, web apps, all of these different platforms, which need data from all of these sources. And by sources, I mean your databases, your services, your SaaS services. For example, you have like a Stripe API for payments and like search for a different service and whatnot. And you have your stable data storage with databases like Postgres Yugabyte and versions of that, right? So you have all of these different producers of data which require to be processed by some interface in the middle so that the consumers can access it seamlessly, right? And the interesting problem here is each consumer of the app, each consumer of data is basically requiring different levels of data and from different locations of the client, right? So, for example, your mobile app could be requiring smaller amounts of data compared to a web app, which is in larger screen sizes in general, and different user regions could be possible where your mobile app is accessed by different people from different countries, and your web apps, if it's probably like an admin app, which would be accessed primarily from a particular location, right? So you have different use cases for these consumers. And to tie this all, you need a data access layer in between, which is the API layer. And it takes a lot of time to build and iterate on, right? So we'll look at how that can be solved. So the data access layer could be GraphQL, because it solves a lot of these problems where it allows you to query data from multiple sources pretty easily because the syntax lets you do that pretty seamlessly. You have different shapes of data, multiple data sources, obviously. And because GraphQL is self-documenting, it allows consumers to not worry about the backend infra, the data source that they're querying from, and hence just worry about implementing it on the front end, right? So the GraphQL solves like a key bottleneck for data access by being like a schema type system by itself, and hence you have consumers accessing data through GraphQL, which makes it easy and abstracts away the producers of data, right? And GraphQL is not easy to build on the server side, so Hasura basically comes in by actually automating a lot of these processes where you get instant CRUD APIs on top of all the data sources, right? So let's look at what Hasura brings to the table. So Hasura gives you instant GraphQL on all of your data, whether it is a new database or an existing database. So you can have an existing Postgres with the data, and you can just connect Hasura and then quickly get API access, right, for your CRUD operations. And it also comes in built-in authorization, which is pretty important for like a security angle where you have data access now through APIs. Now you want to actually securely access it, not allow it to be accessed by the public URL, right? And once you go into the production operations and logistics, you need caching, you need rate limiting, you need all of these monitoring features as well, which is available with Hasura Cloud once you go cloud native. Cool. So let's look at scaling an e-commerce app as an example, so that we go into each parts and why we require an API first approach and what are different components required there. If you take an e-commerce app, you have these product listing pages. You have products available for querying across the globe. Let's say your products are available across the globe by different regions. People could order from different countries and could ship products to them. So you have order placement and products both available across the globe. Products is basically read, so you read data from the database. Order placement is write, so you write data into the database. You have mutations with GraphQL, which does that. And for example, you have an admin interface, which is primarily focused on just the logistics part of managing your orders from a particular region. And this could be just one particular region, for example. But whereas your order placement and querying your products will be from multiple regions across the globe. Okay? And obviously payments data as well comes into the picture post order placement, where due to regulations or due to some other criteria, you will have payments data stored in a particular region as well. So you have data access problem solved with GraphQL, but you also have different use cases for different data sets. And depending on which consumers access it and from which region, you will want data to be accessible from all of these different sources and regions and locations, right? So now looking at the components, so we've seen the different components, the e-commerce app that will be required for querying and mutating the GraphQL. Let's look at the actual components that will serve the app and actually be used. So you have a front-end app, which will serve the e-commerce app. Could also be a mobile app, for example. You have an API layer, which will surface between your database and your application. And you actually have the database layer at the end, right? Now, you need all of these individual components to scale independently, because you have your front-end app, which needs to serve clients across the globe and across regions, which means at any point of time, it could also be getting a spike in traffic for a particular region as well, which means your front-end should be scalable first. It should also be served with limited latency, which means it should be available at the edge for different people, depending on which region they are in. And the next step is to optimize the API layer, right? Where you have the API layer available on different regions again. And finally, you have the data store, which is in this particular case, Postgres. And if you want like a distributed use case, you want Yugabyte, right? So here, the app can scale out on its own. You have front-end apps that can, if it's a static app, which is products being listed, it could scale out for millions of users. And if it's an API layer like Hasura can be run as multiple instances connecting to the same database, but then fetching data from different regions, right? So Hasura can be scaled horizontally, and you have the database layer, which is at the last. And you also need to have databases at multiple regions. And that's where you need distribution of your SQL database, which is where Yugabyte comes into the picture, where you have Yugabyte, which can be scaled automatically and which could be geo-distributed as well. So this would be perfect use case for an e-commerce app, like the scenario that we'll discuss so far. So for example, you have an order placement coming in from a European region or from a US region, and you have the front-end app already being served from that particular region. Hasura is also running on that particular region. Now you want the database to be available there, and you don't want that to be, let's say, in the Asian region, for example, which means the latency for the API to contact database is obviously high. And that's where Yugabyte solves the problem by being geo-distributed and scalable by default. So you have like a API layer, Hasura, which is compatible with Postgres and all of its variants. and thereby Yugabyte becomes that Postgres variant, which is the distributed database, right? So you have now Yugabyte instances running in different regions. So you could have one Yugabyte per region, like one in Europe, one in US, one in Asia. Even within the region, you have multiple zones on which the database can be running. And which means you have fast reads, so limited latency on reads. And you will have writes which can take its own time because they're asynchronous and it could take time to replicate. And in most cases, it could be event driven where you have some writes and you have some asynchronous operations which are event driven, like sending email, for example, which will happen, non-blocking operation, which will happen instantly. So we have Yugabyte, which is solving this distributed SQL layer by coming into the middle, right? So now looking at all of this, this all sounds like a CDN that's for a dynamic data use case. For example, like an e-commerce app, you have prices which are changing for products. You have order placement, which would mean the inventory data needs to be updated for stock availability. So data is dynamic, but you need fast access across the regions. So with Hasura Cloud, you have a global distribution of the API layer and security is there by default, which means you have access control rules set up. So that will solve the API layer security. You'll also have rate limiting and other monitoring features, which will let you configure the level of security that you want for your application, right? And with caching, which is going to solve one more level of problems within the same region. So for example, if you're running Hasura in Europe and the database is also in the Europe region, you can still reduce the latency even more by caching data, which means Hasura doesn't need to contact the database every single time a static query is made. For example, in an e-commerce scenario, you have products being fetched pretty frequently, and that data can be cached. Commonly accessed attributes of the product can be cached, which Hasura can cache. And whenever your front-end client requests data for that kind of a scenario, Hasura Cloud can just not make a database hit, but can actually fetch data from a cache store that it maintains and then give it back to the client pretty quickly. So that's another level of optimization in terms of performance that you get, and within the same region where the client is requesting data from. So that's a pretty sophisticated CDN kind of a use case where you have all the layers of your application being in the same region, being at the edge for the user for the high performance querying and latency being improved, right? So you have front-end apps which can be deployed usually with serverless solutions like Versal or Netlify, of these Jamstack solutions which come in, or you can even put it in kind of S3 for static sites, and you can have it multi-region as well, which will load from these regions. So combining your front-end app, which is already serverless, and combining your API layer, Hasura Cloud, which is highly available and available across all regions with caching. Now, the last piece is combining it with the distributed SQL store, which would also mean that now you have a very powerful combination of your front-end app scalable with the API layer, with the database layer as well. So you not only get high performance, but you also get high availability and high scalable attributes. And in cases where you're using the cloud versions of Hasura Cloud or Yugabyte DB Cloud, you will have all of this taken care automatically. So you don't need to do the operation side of things. The infrastructure bit is already taken care by the CDN layers, right? So now let's look at a quick demo with Hasura Cloud setup and a Yugabyte demo. All right, so let me go back to my Hasura Cloud dashboard. So I have a bunch of projects here set up, but for example, this particular one, which I've created, let me go projects. Yeah. So this particular project, which is magnetic for the 34, let's look at the settings for this project. So this is available on this particular endpoint. So this project exposes a GraphQL API on top of databases, and we look at what databases it supports. It's deployed with a region and currently in India, so deployed near Mumbai, Asia Pacific, AWS regions. And it has an admin secret for like this security that doesn't let access for other people by API. So now these are basic settings. Let's look into the API console that Hasra has. We have like a bunch of tables here configured. So if you look at the data manager, we have a database called Yugabyte configured, which is a variant Postgres. And click the connection string, it will show us the Yugabyte database URL PNB variable that's going to be used. If you look at Yugabyte database URL, this would be the URL that's used. So we already have the Yugabyte cluster created. So let's look into the Yugabyte cloud cluster. So if we go here, this is the Yugabyte cloud cluster that's been created. And this is going to be using an e-commerce schema. So we will have tables coming in from the e-commerce schema, orders, tables with the user data, and one. So let's look at the table structure here from the Yugabyte dashboard. So we have all of these products. We have orders, we have address, we have site admin, users, and products. Cool. So now let's actually look at querying this data. And let me actually open the console by mentioning the console here. In fact, if I can just cancel. Right. So we have a bunch of APIs being generated. So if I go into the data manager, in this case, I have the Yugabyte one. And if I go back here with this project, I have Yugabyte along with a couple of other Postgres databases as well. And here the use case is I have multiple databases for different use cases. I have one Heroku database for just reads, which are not required to be highly available or high performance. So I keep my secondary data in that Postgres database, and I keep my primary e-commerce app data, which is highly accessible and highly available on Yugabyte. So I have the Yugabyte cluster connected. So let me open that up. And this would have tables coming in from Yugabyte. So I'm going to open the public schema, and we have the tables appearing. So we'll have to track the tables so that they're exposed from the API layer. So now the tables are tracked. Let's look at the product table, for example, and we should have the details of the products listed down. We have some data that's available already. So we have all of this data coming in. Now let's go to the API console and make a simple query, which should be fetching products, which would fetch the ID, name, and probably the image URLs. And I want to put a limit 10. And there you go. So you have all of these products listed down. And if you look at the analyze query, this would show what is the SQL query that's generated for this GraphQL query. And here we see that there is select for all of these columns from the table public.rock, and we've gotten with the response. So we can optimize the database response based on the execution plan that we have here. All right, so now we have a simple query fetching data for products from the Yugabyte cluster, which will automatically load balance for us. And let's now go to remote schemas and add this countries API. So we have this countries remote schema, which would add data for different country codes and cities. Right? This is a publicly available data, which is available as a GraphQL API. Now, once I add this, I can start making query for this country API code. Let's say let's fetch the name. This will be India, and maybe some other column, which is capital, for example. So we have a couple of columns and names fetched. Cool. So now we have this country data, and we have the order data available in Yugabyte. So let's go to order. Let's look at the columns. We have a country code column. So let's set up a relationship from the order to country code. So this will be a relationship for country code, and this will go to the country's remote schema. And let's look at country code, and this will come in from the column, which is the country code. So what we're doing here is we are basically mapping a column from a remote schema to filter into the order table's country code. So anything which matches that filter, the data can be combined. So there's a relationship that's been defined. I think I should rename this country code data. And let's just save this. There you go. So we have a relationship now set up. Now let's make a query to order ID, and we have country code as well, which is this would be empty because we haven't had any other data. Check file country code data. So this now lets us get the name. This would let us the status, probably billing address and shipping address. This would make a query. So these three columns are fetched from the database, from from a highly available Yugabyte database. And this particular field is being fetched from a country's publicly available GraphQL API. And the data is being joined here, where you have data from the Yugabyte DB joined with data from an external service. which is the countries API. So you have a highly available API, combine data with the not so highly available data with countries API. But the use case is practical because now the admin who's handling reports for this would be able to now fetch data for orders and actually map it out to some country codes, which is probably required for shipping and whatnot. Cool. So that's the demo that I want to quickly show you folks. And finally, on the resources, if you're interested to join and learn Asura, you can head to our Discord. We have a pretty active community, which is about Asura and how to use the API with GraphQL. We have a few learning tutorials for you to check it out. We also have a Yugabyte tutorial on our Learn portal. Let's go to that. So we have a database tutorial specifically for Yugabyte, and you can set up Yugabyte with Asura Cloud to get all of these features that I have talked about to start. Cool. So that's it. Thanks for joining in. And I'll be able to help out in the Q&A.